so important when you pause it.
Yep. All right, Makefiles. Hopefully you can all tell that trying to type all these commands out, if you have a bunch of files, is going to become really, really annoying very quickly, right? Probably. So we have something that was created, Make. It was written in 1976, and it's used to automate all these commands for you. It'll actually make you learn how to use Make, it's going to make your life a whole lot better, okay? Virtually every build system has a Make-like properties to it. You may have, if you use Maven or Gradle, they're another type of build system. They operate similar to Make, they just do things a little differently. They'll argue that it's far better than Make. That's fine, they can. Key thing, even though Makefile was written in 76, it's still used today. I used it at Google. That's what we used internally, were Makefiles. So this is actually a tool not only still used, but is in a way a basis for every other build system that's out there. Okay, how does this work? Well, you have a Makefile. For example, we'll go over here to simple, vim, Makefile. It can be with a capital M or lowercase m. Doesn't matter. The first thing you usually want to do inside your Makefile is to declare some variables. If you took scripting, you can think of a Makefile as a type of script, but it's going to be formatted in a very specific way in order to automate things. Let me make sure I follow the slides. So first, they're going to do their flags. So we'll do C flags and sources and CCC. So I'm going to go C flags equals, we'll do -02 for optimizations and warning all. And I'm not going to do any other variables, we don't need them. The biggest advantage here is the second one, which is called dependency rules. Defined under what conditions a given file needs to be recompiled or a given command needs to be rerun, actually. This Makefile is not actually dependent on compiling. You can use it to automate whatever you want. But for now, it needs to be compiled. So what this is saying is that recreate main.o if there's a change to main.c. How do you recreate it? You run this command down here. So, I jump over. We had simple.o in our example. It's dependent on simple.c. Oh, and make sure when you're under the rules, you use the tab. The one weird thing about Makefiles is it has to be a tab. If you put in spaces, it will not work. It has to be a tab. That's the one weird thing about this. It's 1976, guys. It's just how it is. So GCC -C. We'll go ahead and use that C flags we just created, and simple.c. And if we wanted to create one for another, we could. And another, perfect. Okay, now, all right, well, we got that so far. To show you what's going on, if we want to make simple.o, it says it's already up to date, probably because we didn't make a change to it. So if I go into simple.cpp, we'll go and add a space. Now I do make simple.o. Oops, did I rewrite this? Forgot the PPP, silly me. I probably also did that in the, yeah. You know what else is going to cause some issues? Yeah. There we go. There it goes. Make simple.o. All right, I did it. Make another .o. Already up to date. Well, let's make a change to it. Okay. Probably doesn't seem like we've done too much that has helped. That's fine. Let's see. All right. How can we make this helpful? It's good. So we'll do it. That's the way the slides want it. Perfect. Usually up top, you want to create an all command. And an all command is what it depends on. So in all, you need to have simple.o and another .o created. And then inside of here, you're going to do GCC. We'll just say star.o. Let me put in the C flags first. Star.o, and we'll create simple. So it's saying, first, make sure simple.o is correct. are up to date. Then make sure another .o is up to date. Once those two things are up to date, go ahead and compile it. Okay? So if I do make, it just compiled everything, probably because I didn't have to make a change. Well, let me go and make a change to simple.cpp. We'll add another space. Type in make. It compiled it because it detected the change, then relinked it and put it together. You now see why this is helpful. All you had to type was make. You want it to become even a little fancier, you could go inside your Makefile, and then right after you compile it, run it. So it links it together, then it runs it for you. So every time you type make, it'll go and see if there's a change, update by recompiling it, link it together, and go ahead and run it. Now all you have to do is type the word make. Is that easier? Okay. Good. Okay. Multi-source program. When we start doing header files, you're going to have your .os probably depend on your header file. So if there's a change in a header file, it'll recompile the C file as well. That's perfectly fine. It is very common to create a rule for clean. Let me do that right now because it is very good practice to be able to clean everything up. So let's go look at what we have. We have a bunch of .os and a simple. So we're going to go over here, Makefile, clean. rm-f, don't ask me, just do it, -o and simple. So if I do make clean, it removes everything. Notice that I call it clean. There's nothing extra here. There's no executable, no object files, just the basics of what you need. So when I type in make, look how it recompiled both those CPP files, then linked it together, and then ran it for me. So also, if you just need to refresh and clean everything, just do make clean, make, and it'll redo everything. Yes.
So it doesn't run clean by default.
No. What make does, what make is actually doing when you just type make, is that it looks inside your make file and runs whatever's first. I could call this whatever I wanted to, and it would still run it. It's whatever, it just finds the first rule and runs it. That's why it's good practice to make your first rule called all, so because that's what you're doing, you're making all, and you're going from there. Now make is a little bit of a different language, but it does allow comments. Pound, this is a comment. Just like everything else, it's ignored. Now, notice I had a variable called cflags. That's where the flags I was giving it, -02 -wall. That's being pasted right here. So if I wanted to add debugging flags, I just put -g, hit make. Well, I'd have to do a make clean because I changed the flags. And then now we compile it with the flags. Notice how the -g is there while it wasn't up there. Hence why you probably want to use at least the variable called cflags, just so you could change which flags you're sending. Okay. Commands can be anything. Notice that in clean, even though I ran the rule clean, it did not do compilation, it did remove. You can use this tool to automate whatever you would like to. It's not limited to G++. You can do multi-lines, like I showed you with that all command. I compiled, and then I ran it afterwards. Perfectly fine, as long as you have one tab. You must use tabs. Make param, like I did make clean or make some parameter, or if you want to make a specific O file, you can use it that way as well. For your make files. Now, this is beyond the scope of the class, but I do want to at least alert you to a couple of tools. Make depend will actually go into your C file, C++ file, and generate the make file for you. Isn't that nice? But for now, write your own make files just to get used to it. You can try and learn make depend, it'll probably confuse you at first. The other thing is called configure. It also makes make files. It's part of the GNU system, and what this one does is it figures out what's on your system, and then it will actually compile certain things for you if you need new libraries, or generate what needs to be compiled if you need new libraries. This one is really complicated, but useful for very, very large projects. Okay. At least I got this far. Any questions? Good. We're going to go over lab 2.